Hi everyone. Today we're going to look at some factoring shortcuts. These are some easy tricks that will help you factor equations more quickly. Things to remember is that decomposition will always work if that equation is able to be factored. So if you are stuck, you can go back to decomposition. It will always work. And if you need a reminder on decomposition, please go back to the decomposition video. And the other thing that you want to remember is to always common factor first. So let's start with some simple trinomials. So for our first trinomial, we have x squared plus 2x minus 15. Now we would start the same way, and let's say that we're looking for two numbers that will multiply to negative 15 and add to positive 2. So two numbers that will multiply to negative 15 and add to positive 2. Now, you might be one of those people that can just pick these numbers out, but if not, that's fine. Just write down the numbers that multiply to 15. So we have 1 and 15. 2 doesn't work because it's not even. 3 and 5 also work. So we're looking over here. It has to multiply to a negative number. So we know that one of our two numbers will be negative. And since it has to add to positive 2, we know that the bigger number is going to have to be positive. So 3 is going to be the negative one. And you can do a double check. Negative 3 times 5 is negative 15. Negative 3 plus 5 is positive 2. Now, the thing that we notice is that the numbers that we picked are actually the numbers that end up in our brackets when we do decomposition. So since we have our variable here is x, we're going to write x at the beginning of both brackets. Then we're going to take these numbers that we figured out and we're going to add them into our brackets. So x minus 3 and x plus 5 is our final statement for this trinomial to be factored. So let's take a look at our second example. So we're looking for two numbers that multiply to negative 30 and two numbers that add to negative 1. So, and I guess I should say here that there's no number out in front, there's no coefficient out in front of that x, you can assume that it's a 1. So then we should write down all the numbers that multiply to 30. So we have got 1 and 30, 2 and 15, 3 and 10, 4 doesn't work, but 5 and 6 work. So 5 and 6. Now, if we're looking for numbers that add to negative 1, obviously the first three sets aren't going to work. But 5 and 6 have a difference of 1. So if we wanted to add to negative 1, because it has to add to a negative number, our bigger number is going to be the one that's negative. So you can do a double check. 5 times negative 6 is negative 30. 5 plus negative 6 is negative 1. And these are the numbers that are going to be going into our brackets. So x plus 5 times x minus 1. And that's our equation in factored form. The next step is difference of squares. Now these ones are very identifiable. You're looking for two numbers that are being subtracted and they're both perfect squares. So you can square root both numbers. Okay. Now for this, you want to open two sets of brackets. All right, the same way that we did with simple trinomials. You take the square root of the first term and you put it at the beginning of each bracket. You put the square root of the last term at the end of each bracket, and then one of the brackets will be positive and one will be negative. The reason for that is that it actually will you'll end up getting rid of your middle term. Okay, same thing over here. We have a slightly more complicated question, but both of these terms are perfect squares. We can take the square root of 4x squared. So we're going to open two sets of brackets. The square root of 4x squared is 2x, so that's going to go at the beginning of both of our brackets. Then the square root of 49 is 7, so that will go at the end of both brackets, and one bracket will be positive and one bracket will be negative. Okay? The next shortcut is for perfect square trinomials. Now, these are probably the ones that are the hardest to identify. And looking at the perfect square trinomials in a simple trinomial, you would probably just go about it the same way that you would with that simple trinomial shortcut. So you were looking for two numbers that multiply to 9 and add to negative 6. You would probably just write x plus 3 times x plus 3 because 3 times 3 is 9, and 3 plus 3 is 6. The special thing about these trinomials is that you can write it as 1 bracket squared, because we have the exact same bracket. Now, the way you identify a perfect square trinomial is if the square root of the first term and the square root of the last term, if you multiply those and doubled it, you would get your middle term. So the square root of x squared is x. The square root of 9 is 3. And if you doubled that and multiplied them, so 2 times x times 3 is equal to 6x, which is our middle term. So it's harder to identify, and you might just end up using a different shortcut, and that's fine. Now, if we look at our other one, our other example, it is a perfect square trinomial, but it's not a simple trinomial. So this might be one where you might use decomposition because you look at it and say, I don't know where to start. But if we look at this, you can say the square root of 9x squared is 3x. Let's make that square root sign a little longer. And the square root of 100 is 10. And 2 times 3x times 10 is 60x, which is our middle term. So what happens here is you would open two sets of brackets. You put the square root of the first term at the beginning, so 3x and 3x. You put the square root of the last term at the end, so 10 and 10. And then the sign that goes in the middle is whatever the sign is of your middle term. So we're going to write a negative here and a negative here. Or you could jump right to 3x minus 10 squared if you realize that it was a perfect square trinomial. Now, that being said, let's say for this one you didn't notice that it was a perfect square. If you use decomposition, you would come up with the exact same answer. All right, so that's why decomposition will always work if you forget some of your rules. Now, the thing to always remember is that you have to common factor first. So if we look at our first example, we want to remember that it looks like all of our terms are divisible by 2. So we want to factor out that 2 first. So we've got x squared minus 6x plus 8 when we factor out that 2. And here, inside of our brackets, we've got the simple trinomial. So we're looking for two numbers that multiply to 8 and add to negative 6. So our options are 1 and 8 and 2 and 4. And you can notice that it's multiplying to a positive number, but adding to a negative. So we know that both of our terms are going to be negative. And negative 2 and negative 4 end up multiplying to positive 8 and adding to negative 6. So we are going to open up two sets of brackets, and we're going to have x minus 2 in the first bracket and x minus 4 in the second bracket. And the 2 that we factored out does stay in front. So don't forget to keep that 2 in front. Okay, same thing, you have something that looks kind of like a difference of squares for our second example, but it's not quite. You can't take the square root of 2 and you can't take the square root of 72. But if we factor out that 2 first, we're left with x squared minus 36. And then you can say, oh, this is actually a difference of squares here. So the same thing, the 2 will stay out in front. I'm going to open up two sets of brackets. I'm going to put the square root of my first term at the beginning of each bracket, the square root of my second term at the end of each bracket, and because it's a difference of squares, one's going to be positive and one's going to be negative. Okay, so I hope that some of those tricks have helped you. Feel free to leave any messages below if you have any questions. Thank you.